Hello Year 8, and here is your 5 a day. And let's go through the answers. So, we want to find the radius of a circle. It's got a circumference of 30. So, of the two formulae for the circumference, we've got 2 pi r and we've got pi d. We want the one with an r because we're finding the radius. So we write c equals 2 pi r. We substitute in what we know. We know that the circumference is 30. Now I want to find the radius, so I divide both sides of my equation by 2 pi. Now I can see there that I can simplify this because 30 and 2 have a common factor of 2. So if I just go up here, because I've run out of space, I can say that r equals 15 over pi. And my circumference was given in centimetres, so my radius will be centimetres too. In these two triangles here, this angle is equal to this angle, this side is equal to this side, and this angle is equal to this angle. So these triangles are congruent by angle, side, angle. However, this statement itself is not true because angle A does not correspond to angle B. So the actual statement should be triangle AED is congruent to triangle. So angle A corresponds to angle C. Angle E corresponds to angle E. And angle D corresponds to angle B. So AED is congruent to CEB. So 3 significant figures is 3.49, the 9 rounds up, so it's 50. I'm going to write the 0 there to show that I have considered 3 significant figures. Scientific notation, so it's going to be multiplied by 10. And my decimal point was here. Let's think how many times it's moved. 1, 2, 3, 4, 5, 6, 7. I can't do 0.35 divided by this 0.007 very easily. I can rewrite it as a fraction though. And all I want is my denominator to be an integer. To make this an integer, I need to multiply by, if I multiply by 10, it's 0.07. 100, it's 0.7. So I need to multiply by 1,000 over 1,000. So this doesn't change the value of the fraction because effectively I'm multiplying by 1. But now my denominator is 7. My numerator, so my digits jump up 1, 2, 3. So that's 350. You might be able to do this in your head. 350 divided by 7 is 50. Because 2 is a factor of 22, I can start by dividing both sides of my equation by 2. Then I can subtract 7 from both sides. Then I can divide both sides by 6. 4 and 6 share a common factor of 2. So I can divide the numerator and denominator by 2 to get y equals 2 over 3 as my solution. Okay, so today we're going to be looking at area of composite figures involving circles. Composite means figures made up from different shapes. So we're going to look at finding areas of shapes involving circles and also rectangles, perhaps some triangles. And we're going to look at finding these by adding and subtracting. So this shape here, we're going to be able to find its area. Now, that shape is called an annulus. And the word annulus is just the Latin word for ring. And you'll see it's a ring shape. So to be able to find the area, we need to be given 2 radii. One is the radius of the larger circle. So in this case here, my radius is 5. And the radius of the smaller circle that has been cut away from the larger circle. And so to find this darker purple shaded area, we find the area of the larger circle and we subtract the area of the smaller circle. So remember, area of a circle is pi r squared. And so the area of this annulus is the area of the larger circle, which has a radius of 5, subtract the area of the smaller circle, which has a radius of 3. Now I can evaluate this bracket, so pi times 5 squared, well 5 squared is 25, so I can just write that as 25 pi. 3 squared is 9, so I can write the second bracket as 9 pi. Then I have 25 pi minus 9 pi, which leaves me with 16 pi. It's an area. My radii are given in centimetres, so my area is in centimetres squared. Use that example to help you answer question 1 from exercise 14D. Pause the video while you do that, and don't use pi is approximately equal to 22/7. Use the pi button on your calculator. And this should be your answer to the nearest whole number. Okay, let's look at this example. Here we have a square with a circle cut out of it. So to find the area of this remaining region, this darker purple region, we need to find the area of the square, which is just the side length times the side length. If I wanted, I could write 8 squared here instead. And I subtract the area of the circle. So that's pi times the radius squared. Now I can evaluate the first bracket. 8 times 8 is 64. I can evaluate the second bracket. 3 squared is 9, so that's 9 pi. And 64 is a number. 9 pi is also a number, but it's better to leave it in terms of pi. We were told to leave it in terms of pi, so I cannot simplify this any further. It is an area though, so I need to give my units of measurement. My lengths are given in centimetres, so my area is in centimetres squared. Now I might cut 2 circles out. What would I do in this situation? Well, I've still got the area of the square, but now I'm subtracting 2 lots of the circle. So that's 2 times the area of the circle. Again, I can evaluate this bracket. I can evaluate what's inside my second bracket. Then remember, this means 2 times. So that's just 64 minus 18 pi. And again, it's an area. My units are centimetres squared. Pause the video now while you have a go at questions 2 and 4. Just do question 2 in terms of pi and just use the pi button on your calculator for question 4. Here are the answers for that. Please make sure you mark your work and make sure you're showing your working like I did here. So at least 2 lines of working, possibly 3 lines of working per question. Okay, so in this question we have a square and we've got 2 semicircles cut out. we need to find out the side length of the square. Now, the thing about circles and semicircles is that the distance from the centre to the circumference is the same. So all of these lengths here are the radius of the circle. I'm told that the radius of the circle is 5 centimetres. So I know that this is also 5 centimetres and this is 5 centimetres. And same with this semicircle over here. This is 5 centimetres and this is 5 centimetres. So the distance across the square, which is the same as the length of one of the sides, is 10 centimetres. The value of the remaining area, what this is asking for, is this area and this area. And we're obviously not going to use pi equals 3.14, we're just going to do it in terms of pi. So the area left is the area of the square, which is 10 times 10. Again, we could have written 10 squared there if we wanted, minus 2, because we've got two semicircles, the area of the semicircle. Remember, the area of a semicircle is the area of a circle, so pi times 5 squared divided by 2, because it's a semicircle, it's half of a circle. So we can evaluate the first bracket. Now, I'm dividing by 2 and multiplying by 2. Those things cancel each other out. And what we could actually see here is these two semicircles, if I put them together, they would make one whole circle. So this is just the same as saying minus pi times 5 squared, which is 100 minus 25 pi. And I cannot simplify that any further unless I wanted to put it into my calculator, which I could do. I would type 100 minus 25 times pi, pressing the pi button. And so let's round to one decimal place. That would give me 21.5. My lengths are given in centimetres, so my area is centimetres squared. So this is the exact value of the area. It says the approximate value, so I'm going for this one that I've rounded to one decimal place. So now you can have a go at question 7. Pause the video while you do that. Here's the answers to question 7. And if you've got time, you want to challenge yourself, you can have a go at these extension questions, which are 9, 10 and 12. And here are the answers to those. The answer to question 9 won't be exactly that, because obviously you're not going to use pi equals 22 over 7, you're going to use the pi button. Please ask if you have any questions. Thank you.